But in solid state, the first topic which one we are going to discuss in that one, that will be the crystal system. And first of all, we know about the what is a crystal lattice, what is a unit cell and all. So we are having a different 7 type of the crystal systems are there. The first topic I'm going to discuss seven types of crystal systems. But for these 7 types of crystal system, in every exam we are getting these kind of the questions. What are the 7 type of the crystal system? So this is a small trick which one I have made for that for every student. That is CT, OM, and HRT. Means if you write here as a crystal system, so these 7 are there. One is a C, then T, then O, M, then H, R, and one more will come as a T. One C stand for cubic, T stand for tetragonal, O stands for orthorhombic, M stand for monoclinic, H stand for hexagonal, R stand for rhombohedral, and one more T is there. One more T that will be called as a triclinic. So just remember the term CTOM HRT. For that one cube, we are having their edge length as well as we are having their axial angles. So what is the edge length for that one? Let us say edge length is here A equal to B equal to C, then B not equal to C, then all are not equal. Then repeat the back side. All are not equal. B not equal to C, then all are equal. But for triclinic, for triclinic, all are not equal, that you remember. So it is a way to remember. First 3 is here. All are equal, B not equal to C, all are not equal. Then repeat the back side. Not equal, B not equal to C, and then all are equal. Last one is what? All are not equal. Then after that, axial angles are there. That is the angle between the two edges are called as a axial angles. What is that? Alpha equal to beta equal to gamma equal to 90. First 3 is as it is. First 3, alpha equal to beta equal to gamma equal to 90. Last one is, alpha not equal to beta, not equal to gamma, not equal to 90. But this 3 is there. The remaining 3 that we have to by head. I'll write with the red color. What is that, Alpha equal to gamma equal to 90, but beta is not equal to 90. Other case में alpha equal to beta equal to 90, but gamma equal to 120. And last case में alpha equal to beta equal to gamma, which is not equal to 90. So these are the 3 are there. So what we wrote, beta, we wrote the axial angles, we wrote edge length, we wrote cubic system. Then we have to write the possible variations for that one. What are the possible variations are there? Possible variations means it may be one of the cube. Let us say 1, 2, 3 orthorhombic is there. It may be a primitive unit cell, body-centered unit cell, face-centered unit cell, end-centered unit cell. I repeat, for the first 3, the cubic, tetragonal, and orthorhombic, the third one will have a possible variation is a primitive, body-centered, face-centered, and end-centered. At the top, we are having a primitive, body-centered, face-centered. Then primitive, body-centered. Fourth one, primitive, end centered. Then last three is there, primitive, primitive, primitive. You can count total 14 lattices are there. 1, 2, 3, plus 2, 5, plus 4, 9, plus 2, 11, 12, 13. We are having 14 brevis lattices, right? So this is a way to remember all the cubic. Suppose, suppose I want to go with a primitive unit cell. But a primitive is also called as a, simple unit cell. But a simple unit cell means, see, it is a cube and constituent particles, that is the atom, molecule, ions, they are present only at the corner of the cube. Means in the primitive, atoms are present only at the corner. 1, 2, 3, 4, 5, 6, 7, and 8 for primitive. Second one is that key body centered cubic unit cell. Body centered cubic unit cell. For this one, constituent particles are present at the corner as well as the center of the body. See, these are the constituent particles are present at the corner as well as the center of the body. See, corner means 8 are there. And one will be there at the center of the body for body center. But one more is there called as a face centered cubic unit cell. Face centered cubic unit cell. For face centered cubic unit cell, atoms are present at the corner as well as at the center of the faces. These are the corner over. Then center of the faces 1, 2, 3, 4, back side 5, front side 6. And last one is at end centered. End centered cubic unit cell. For end centered, atoms are present at the corner as well as the center of two opposite faces. So these are the 4 possible variations are there for the cubic crystal system. So remember they wrote in this way, beta. CTOM HRT mein, remember the third one, it will have all the 4 possible variations. At the top 3, PBF, then PB, then fourth one P, then remaining 3 are the PPP. So we are having total 14 brevis lattices, right? Contribution of particle in the following position. If any constituent particle is present at the corner, its contribution of that particular atom is 1/8 to the unit cell. If any constituent particle or atom is present at the body centered, then the contribution of that particle to the unit cell is only 1. If one of the constituent particle is present at the face centered, contribution of that particle to the unit cell is 1/2. And any particle when it is present at the edge centered, contribution of that particle will be 1/4. Based on this concept, we'll try to get the number of particles present in the following unit cell. One example, beta. In primitive unit cell, we'll try to write the value of Z effective. What is mean by Z effective? But Z effective means it is a number of particle present in per unit cell. So for this primitive के लिए I'm going to write total number of particle per unit cell, and it is denoted as a Z effective. But how many atoms are there? 8 are there. Where these all the 8 are there? At the corner, and contribution is 1 by 8. So that is equal to 1. Z effective for the simple or primitive is equal to 1. But what is Z effective means total number of atoms in the per unit cell. So atoms are present at the corner plus atom are present at the body centered. But a corner how many? 8, contribution 1 by 8. Body centered is 1, contribution is 1. So it is 1 plus 1, that is equal to 2. So total number of atom in the body centered cubic unit cell is equal to 2. See, but in simple में, if you see, we will think that sir in the simple we are having it look like this cube will have the 8 constituent particle. But do you know one atom is contributing its 1 by 8th part to the cubic unit cell. So 8th atom will contribute 8 into 1 by that is 1. So total number of atom in this primitive or simple unit cell equal to 1. Same case here, beta. Total number of atom present in this unit cell look like a 9, but actually 9 is not there, only 2, because the constituent particle which is present at the corner 8 into 1 by 8 and 8 into 1 by 8 and 1 is at the body center, so 1 into 1 total become 2. Same way, Z effective for the face centered cubic unit cell will write, but here Z effective for the cubic unit cell 8 are at the corner, right? Means we can say atoms are present at the corner plus atoms are present at the face centered. Corner how many beta? 8, contribution 1 by 8. Faces how many? 6, contribution 1 by 2. 1 plus 3 and that is equal to 4. So Z effective is 4 for the face centered. Beta end centered में Z effective, atoms are present at the corner plus two opposite faces. Corner 8, contribution 1 by 8. Two opposite faces, contribution 1 by 2. So 1 plus 1 equal to 2. Z effective for end centered also equal to 2. But overall, in our exam, they will ask only these things. Which one, beta? Ki Z effective for the primitive, Z effective for the body centered, and Z effective for the face center. That two only they will ask. I repeat, beta. What they will ask? What is a Z effective means total number of atom present in per unit cell for the different unit cell. So remember, if the unit cell is a type of a primitive or you can say simple, then its Z effective is equal to 1. But if it is a body centered type of unit cell, its Z effective equal to 2. And if it is a face centered type of the unit cell, then Z effective equal to 4. But this is an additional I'm going to tell you, beta. If we are having a beta, this face centered cubic lattice is also called as a cubic close packed, means FCC also called as a CCP. And one more is there, hexagonal cubic packed unit cell. For that also hexagonal के लिए we are having the Z effective equal to 12 into 1 by 6 2 2 plus 3 5 5 plus 1 6. So Z effective is equal to 6 for the hexagonal cubic close pack. But it is a HCP, it is a FCC or CCP, it is a BCC, and it is a simple. So Z effective you have to remember, right? Z effective means we can say it is a total number of atom present in per unit cell. It is a total number of atoms present in per unit cell. But with the help of Z effective, we are going to discuss about the void and all. Let me tell you what is meant by void in this chapter. But a void is called as an empty space. As a revision point of view, I will tell you that directly empty space means what. But there are two type of the voids we are having. Two type of voids are there. One is called as a tetrahedral void and one is called as a octahedral void. But a tetrahedral void means, I'll say one is a tetrahedral void and another one is a octahedral void. Tetrahedral void denoted as a TV. It is a OV. But a tetrahedral void, no, it is formed by 4 spheres and it is formed by 6 spheres, right? Now, based on this void beta concept, what is that? I will tell you. Let us say if we are having, if there are n number of atoms, actually atom will be called as a spheres beta, n number of atoms in the unit cell. That means it have n number of octahedral void and it have 2n number of tetrahedral void. Remember beta, number of atoms is an octahedral void also n and tetrahedral void also double of it. Now based on that, this is a concept which one I wrote here. See beta here. Now, suppose I am having here primitive unit cell beta, Z effective is 1. Can you tell me how many number of octahedral void it will have? So 1. Tetrahedral void how many beta? Double of it. BCC में octahedral void is equal to 2 because number of atom 2 na, so OV also 2. TV double of it. Beta OV is 4, but TV is equal to how many? 8. Here OV is 6, but TV is how many? 12. Right? And one more point, we'll see beta where this tetrahedral void and octahedral void will form. So just for our convenience, I will tell you beta. Tetrahedral void is formed at the body diagonals. This is a point to remember. These tetrahedral voids are there, na? This tetrahedral void are formed at body diagonal. Means indirectly what we can say beta, each body diagonal will have a 2 tetrahedral void. That means each body diagonal have 2 tetrahedral void. But one more is octahedral voids, they are formed at body centered and edge centered of the cube. This is a positions of the void obtained in particular cube. Right beta?